An important theorem specifies that if the limit of the general term as n goes to infinity is not equal to 0, then the series an, and start from 1, goes to infinity is divergent. And also, if the series an and start from 1 goes to infinity is convergent, then the limit of the general term as n goes to infinity must be equal to 0. And just an important note for you, if you compare sequence 1 over n, as a sequence, the limit of 1 over n as n goes to infinity is equal to 0. But the series, the summation of an, and start from 1 to infinity, which can be written as the summation of 1 over n, and start from 1 goes to infinity, which we call it harmonic series. This is a divergent series, which is called harmonic series is divergent. And again, please note that the limit of 1 over n as n goes to infinity is equal to 0, but it doesn't guarantee that the series is convergent. Doesn't guarantee that the series 1 over n and start from 1 to infinity is convergent. So if the limit of the general term is equal to 0, still we have to run other tests to make sure our series is convergent or not. Example for you. Question says, analyze the following series, the summation of n squared divided by 5n squared plus 4 and start from 1 and goes to infinity. Well, an, or the general term, is equal to, this is your n squared divided by 5n squared plus 4. Let me go back to the theorem that I just learned. My theorem says if, super important, if the limit of the general term is not 0, then for sure I have a divergent series. So take a look at the limit of an as n goes to infinity. This limit is n squared divided by 5n squared plus 4 as n goes to infinity. Officially, if you divide by n squared to show all the steps as n goes to infinity, this is equal to the limit of 1 divided by 5 plus 4 over n squared, n goes to infinity. But please note that 4 divided by infinity is 0. So the limit is 1 over 5. The limit of general term of the series is not 0. So since the limit of the general term of the series is not 0, then the series is divergent. So we are analyzing the series, everybody. It's a common mistake that students say, oh, since the limit exists, so the series is convergent. That is wrong. Common mistake on exam. Usually a student write, since the limit of n squared divided by 5n squared plus 4 as n goes to infinity is equal to 1/5, and it is a unique number, so series is convergent. This is absolutely wrong, everybody. We are not analyzing a series. We have a new mathematical object. This new mathematical object is the summation of these terms. So when you see the summation of these terms, you are adding these terms together. We have a criteria. The criteria says, hey, if the limit of the general term is not 0, then the series is indeed divergent. So take a look. The limit of this general term is not 0. So for sure, you can say that the series is divergent.